Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, we have another customer requested topic today. Here it is. The indirect move instruction. Indirect moves are extremely useful, but they're not fully understood by all users. Today, we're going to fix that. Let's get started. Today is a pretty short, concise topic, but we're going to cover a few things. Before we dive into the indirect move, how it's used, where it can be used, those sorts of things, we'll take a quick review of move instructions in general. And then we're going to get to a question asked by the specific requester of today's topic, and that is this: can you use the indirect move instruction with structured variables? We'll get that answered, and there'll be plenty of demonstrations throughout. Here we go. Okay, so what are move instructions? Well, these are a class of instructions in Horner's ladder logic, which allows programmers to move data around in a variety of ways. You can set a variable to a constant value. You can set an array of variables to a range of values. You can copy data from one variable to another variable, and you can copy a whole series of values from one variable to another. And of course, there's also shift and rotate instructions, which we won't cover in much detail today, that allow you to move data, up or down inside of a variable array. Now, before we get on to the rest of our topic today, let's just get into Cscape and take a quick look at these instructions. I'm in Cscape 10. This will look basically the same in Cscape 9.9 though. Here are our move operations in our project toolbox. And let's start with the move single. So that's the simplest move command. You can move either a constant into a variable or move data from one variable into another. Then we have the block move. That's where we can move multiple values. So in this case, we're going to move 10 values from temperature readings 0 through 9 into temperature history 0 through 9. Okay, so that's moving multiple values. That's the block move. With the fill block, you take a single value, in this case 0, and copy it over into multiple variable locations. So in this case, we're taking 0 and copying that into temperature readings 0 through 9. So all of those locations will have a value of 0 when we're done with that instruction. Okay, and then we have the constant move block. That's very useful because you can take any number of constants and just type them in here and fill in the values that you want in a variable array. So in this case, we've got 5 separate constant values that are going to be copied into default set points 0 through default set points 4. And this number is not limited to 5. You could literally do 20, 30, 40 different values in this single instruction. Really useful. And then I'm not going to go into any detail today, but we've also got a shift register instruction that is part of the move, as well as the rotate instruction. So these are also great instructions that I've covered in other live streams on the channel. Now let's talk indirect moves. So indirect moves are similar to the block move I just showed you. Remember, the block move is where we're able to move multiple values from one variable array to another. However, an indirect move has a key difference, and that is this. It allows the source location that you're copying from to be a variable, so it's not always the same, or the destination where you're copying the data to can be a variable, in other words, not always the same, or both can be a variable, both the source of where the data is coming from and the destination of where the data is going to. Okay, so that's what makes the indirect move unique. Let's dive into Cscape and take a look. We're back in Cscape. Now I'm going to show you a couple of examples of indirect moves. In our first example, let's imagine we have 100 different set points we could use for our machine, and the specific set point we want to use is going to be depending on what part we're running. And each part, and there could be up to 100 parts, each part we're going to run has an index from 0 to 99. that directly lines up with the index of the array of set points that we have established. Okay, so what we need to do, depending on the current part index, is select the appropriate set point for our machine so we can continue operation. All right, let's take a look at this indirect move instruction that we've programmed to get the job done. All right, so our source is variable. In other words, our source is that array of set points, and there's 100 of them from 0 to 99, all right, in terms of the index for the array. So because we aren't always pulling from the same source location, we select indirect here, and we have to specify a variable as our offset. Now in this case, it's very simple. Our part index directly correlates to the offset within the variable array for the machine set point storage variable. So if our part index is 50, then we know that we want to pull from machine set point storage 50. All right, so that's how we configure the source. Now our destination is always the same. And in this case, we're not even moving data into an array. We're just moving it into a simple variable called current machine set point. And because it's a simple variable, we're limited to just one word, of course, which is all we need in this scenario. So here's our first example of copying from a variable source into a constant destination. All right, so that's our first example of a indirect move. Now let's look at another example, which is kind of the opposite. In this scenario, we're going to have a constant source that we're going to copy into a different location on the destination. All right, so in this case, imagine we have a machine with multiple stations, and depending on what station we're currently on, we're going to store the current temperature away in a temperature readings array. So let's take a look at that. All right, so again, our source, we're always copying the same data, so it's direct, not indirect. And it, again, is a simple variable. It could be from an array. It doesn't have to be a simple variable, but in this case, simple variable works fine. So we're going to copy the current temperature, but where we copy it is going to vary. So that's indirect. We're going to copy it somewhere in this array, okay, depending on what station number we are currently operating on. Now, again, with these two examples I've given you, the offset is very simple, right? It's got a direct tie-in to the index, either in the source or the destination where we're dealing with based indirect. However, in a more complex scenario, you may have to calculate the offset with another rung of logic to, calculate specifically where in that array you either want to grab the data or place the data. But in this case, these two examples, it's been pretty straightforward. And again, because we're copying from a simple variable into an array, we're just limited to one value that we're copying. If we were moving data from one array to another array, then we could be moving multiple values simultaneously. All right, so those are a couple of quick examples of different indirect moves that you could use in your logic that are extremely useful. So hopefully you've seen how useful indirect moves can be. All right, you can use them like I've shown you to retrieve a set point from a list of set points. I also showed you how we could store data in a different location in a bank or an array of historical data. It's very often used to retrieve a value to test. So if you've got an array of, half a dozen values and you want to look for if any of those values are above an alarm level, you're going to go through one at a time, incrementing your index and examining each member of that array to see if it exceeds the alarm value. So again, you're going to use indirect moves for that. There's also advanced cases where you can use indirect moves to help you create loops in ladder logic, believe it or not. I know we're always really careful of using loops because, you can end up with an infinite loop, which nobody wants. But if you do it carefully, it works really well. And I've done complete videos on how to do that. So let's just take a quick look at an advanced use like that for using the indirect move. So here's my example. I'm back in Cscape again. In this case, I'm going to call a subroutine in my example that is going to calculate the average from a list of 20 integer values. So maybe I want to do some advanced filtering on 20 analog values that are coming in. And the way I want to do that is by averaging 20 readings together. I could do that, I suppose. So in this scenario, I've created a subroutine that uses the indirect move to help me accomplish calculating the average. So let's take a look at that subroutine. Okay, so within the subroutine, the key points here, and let me find the right spot here, is this. Okay, so one by one, we're going to go through the array of 20 values that we're starting with, the 20 analog values, and we're going to pull out one by one the analog value. We're going to add it to a sum, and then we're going to go back, increment the index, pull out the next value. And then after we've pulled out all 20 values and added all 20 values together, then we're going to divide that sum by 20 to get our average. And all this is going to be executed in a single scan because we've got this loop that we're doing here. And let's take a closer look at how we've configured our indirect move. Okay, so we've got our list of values. These are the 20 analog values I talked about. Again, because we're pulling from a different location every time as the source, this is indirect. Our index is what tells us where within that list we're pulling from. We're going to start that index at 0, and then outside of this block, we're going to keep incrementing it up to the end, which happens to be 19 in this case. And then we're copying that value to a constant location, which is why that's direct and not indirect. And again, as I showed you, outside of the function block, that's where we're adding that value and creating our sum. So that's an advanced use of the indirect move block, but it can be, again, pretty useful in a variety of different situations. All right, now let's answer that question. Can you use indirect moves with structured variables? Now, before we answer that question, let's review structures for those of you who aren't familiar. So what is a structure? A structure is a user-defined data type that allows grouping of multiple related variables of different types under a single name. So on the screen there, you can see I've created a structure called motor, okay? And that motor has 7 different variables grouped within it, okay? And those happen to be of different types. We have 2 integers and 5 reals, okay? Current rating, RPM rating are integers, and you can see after that there are 5 reals. After you've created a structure, all right, then what you can do is create variables that use that structure. So on the screen here, I have a snapshot from the program variable window that shows I have created 3 different variables that use the structure motor: main motor, fan motor, and motor history. And if you look carefully at motor history, you'll see that that is an arrayed variable with a dimension of 100. Now, how can you access a structured variable from within your program? Well, on the left, I'm showing you the variable browser, which pops up whenever you're filling in a variable if you want it to. And that's showing that we have the main motor variable, okay, which is a structured variable, of course, and all the variables within it: current rating, RPM rating, etc. Now, how do you access those individual variables in your program? What do they look like within your program? Well, the overall name of the variable, main motor in this case, is always at the beginning, followed by a dot, and then followed by the name of all the individual variables that are part of that structure. So main motor dot current rating, main motor dot RPM rating. And this is important later, so I'll mention it now, and that is, if you take a look at the amount of data that's contained in this particular example structure that I've created, this main motor structure contains a total of 12 words. It's got 2 integers, motor current and motor RPM, and then the other 5 are real values. So 1 word plus 1 word plus 5 times 2 words is a total of 12 words. And again, that'll be more important later, and you'll see why. Now let's take a look at another one of the variables I created that uses the motor structure, and that is the one that was an array of structures, and that is the motor history variable. So you can see there on the left, there's the motor history variable and all the sub variables beneath it, right? And on the right, you can see that, again, the notation is just what we looked at with main motor, except this time we've also got an index for our array, because the main motor is a array of structures, which means it doesn't take up 12 words total. It takes up 1,200 words, okay? Because each element of the array is 12 words, and there's 100 different members of the array. So that's 12 times 100 words for that particular variable. All right, now let's say we have an example. We're starting to get to the indirect move question here. Now let's say we have an example where we want to store the current main motor values, all 12 words or all 7 different variables that are part of main motor. We want to store those somewhere in the motor history array, all right? And where we want to store them depends on a part index. So if we're running part number 72, that part index directly correlates to the offset within the motor history array where we want to store that data. But we're not just storing one word of data or one total variable of data, we're storing 12 words of data, okay, through 7 different variables. So how would we create an indirect move that accomplishes what I have there on the screen? Well, the first thing we might think is, well, let's program it like this, where our source is main motor. We're always pulling the data directly from main motor, so it's not indirect, so we can program that as direct. Our destination is somewhere in the motor history array, so we'll specify that. But the location could change when we do the write, so that's indirect. The offset where we do the write is going to be directly tied to the part index, and we're moving everything from main motor into motor history, so let's use a count of 1. So let's try programming it that way and see what happens. Well, the reality is that's completely wrong, okay? And there are 3 things that are wrong with that, and let me go through those with you now, and then we'll show you specifically the right way to do that. So first of all, what you specify as your source or destination isn't just the name of the structured variable, it's the first variable within the structured variable for the source and for the destination. I'll show you what those specifically are here in a minute. The second thing that is wrong in what I showed you a minute ago is our count. Our count isn't just a length of 1, but it's the total number of words that we're moving. And in this case, we're moving 12 words of data, not 1, and not 7 because we've got 7 different variables, but 12 because that's how many words we're moving for this word type move. And then the last thing that was wrong is the fact that the offset that we specify for our destination isn't just 0 to 99. It's not tied to the array element number. It's tied to the word offset within the array. Okay, so now let me show you the details on the next screen. Okay, so again, our source is main motor dot current rating because that's the first variable within the structure of the source. Our destination is motor history 0 dot current rating because that's the first variable within the destination. Okay, and then our offset isn't the simple part index, but we had to calculate using another variable called history location where we took the part index multiplied by 12 outside of this function block, of course, to come up with history location, so we got the proper word number that is our offset. And then our count is not 1 or 7, it's 12 because we're moving 12 words. So this is the proper syntax to accomplish the move that I discussed, and that is moving all the data, happens to be 7 variables or 12 words, from the main motor structure over into the motor history structure. So yes, you can use indirect moves with structured variables, but it's not super straightforward. So I think it would probably be a great thing if later on a Horner came up with a structure move instruction that might be a little more straightforward. But you can certainly do it today. You just got to take a lot of care like I showed you here. Okay, so that does it for our topic for today. If you, at the very last minute, want to sign up for basic training, we do have a couple slots available, but you better get right to it. Better do it today because the class is next week. But if you're looking to sign up for Horner training in general in 2026, get to our website and get signed up. Okay, lots of ways to interact with Horner online, including our website, our YouTube channel, and you'll find all the latest Horner news on LinkedIn. All right, next week, we have another customer requested function block. That's probably going to be the theme for February. Lots of customer requested topics. And next week, we're going to show you more of our data sorting function blocks. So lots of folks asking about sorting data. We did a live stream a while back showing you how to use some user-defined function blocks to do some data sorting. We're going to show you some more advanced techniques during next week's show. If you haven't subscribed to our channel yet, don't hesitate to do so. It doesn't cost anything. If you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. Okay, so until next week, let's all get out there and do some good.